Hello everyone. In the previous video, we have seen ternary search algorithm. In this video, we will be looking into ternary search implementation at a glance. Before watching this video, I will recommend you to watch the previous video in which I have explained the algorithm in detail. So to have a quick recap, first we need to initialize the low and high positions, then we need to compute two different middles. For finding both the middles, we have separate formula which is presented on the screen. So once you compute middle 1 and middle 2, you need to compare both the middles with the element to be searched. Now after comparing, there will be four possibilities. First, you need to check whether the element to be searched is equal to any one of the middles. If they are equal, then just return the position and stop. In the second case, the element to be searched might be lesser than the middle 1 element. Then in that case, make high as middle 1 minus 1 and repeat the process. In the third case, the element to be searched might be greater than the middle 2 element. Then in that case, make low as middle 2 plus 1 and repeat the procedure. In the last case, the element might lie between middle 1 and middle 2, then make low as middle 1 plus 1 and high as middle 2 minus 1 and repeat the same procedure. Finally, you will get the element to be searched. Now let's have a look at the implementation of ternary search algorithm in Python language. Now I will be implementing this algorithm with the usage of recursion concept. So first I will be defining a function named ternary search. This function will take four parameters: low, high, array and the element to be searched. So now as stated before, ternary search only works on the sorted data. So here I am taking a sorted data of 5 elements. Next I will be calling the function named ternary search with the parameter low as 0 because 0 is the first index. Next, the position high can be computed by the formula length of array minus 1 because the array indices starts from 0. Next we will pass the array which we defined now. Next we will pass 54 as the element to be searched. So this is how it takes 4 parameters. So now if you remember, as per the algorithm, we need to compute two different middles. For finding both the middles, we have different formula. So we will write the formula for middle 1. The formula is low plus high minus low divided by 3. Here I will be using floor division to avoid any unnecessary decimal values. This formula will give the position of the first middle, which lies in the first half of the array. Similarly, we will define the formula for middle 2, which is nothing but high minus low divided by 3. Here also I am using floor division. By this formula, I will be getting the position of the middle 2 element, which lies in the next half of the array. Next step is to compare the element to be searched with the element which is present on both the middles. So first we will check that the element to be searched is equal to the element which is lying on the middle 1 position. So if so, then we will return that the element is found at index middle 1 and we will stop because the location of the element is found. Next step is to compare that the element to be searched is equal to the element which is lying on the middle 2 position. If so, then we will return the location of the middle 2 element and stop. Now in the other possibility, the element to be searched is lesser than the element which is lying on the middle 1 position. Now in this case, since the element to be searched is lesser than the middle 1 element, then obviously the element to be searched lies on the left hand side of the middle 1 element. Therefore we will make high as middle 1 minus 1 and we will keep low as it is, and then we will repeat the step. Now for this, we have to recursively call the ternary search function with the parameters changed. Low will be as it is, high will be middle 1 minus 1 and the array and the element to be searched will be same. Now in the other possibility, the element will be greater than the element which is present on the middle 2 position. So in that case, obviously the element to be searched will be lying on the right hand side of the element which is present on middle 2 position. For that, we will recursively call the function with the parameter low as middle 2 plus 1 since it is lying on the right hand side, and we will keep high as it is, and the array and the element to be searched will be as it is. Now if the element to be searched is not lying on the left hand side of the middle 1 element and even on the right hand side of the middle 2 element, then there is the possibility that it is lying in between both the middles. So if it is lying in between both the middle elements, then we need to recursively call the function, and we will now make low as middle 1 plus 1 and high as middle 2 minus 1. The array and the element to be searched will be kept as it is. So to summarize, we have found out both the middle elements' position. Then we have checked that the element to be searched is equal to the element which is present on any one of the middles. Then we have checked whether the element lies to the left hand side of the middle 1 element. If so, then we have made high as middle 1 minus 1 and repeated this step. If the element is greater than the middle 2 element, then we have recursively called the function by making low as middle 2 plus 1 and keeping high as it is. And if not both the cases, then we have made low as middle 1 plus 1 and high as middle 2 minus 1. Now let's execute the code and see whether our code is working or not. So you can see that the message has popped that the element is found at index 2, which is precisely true. Find the code for this in the description box. Don't forget to like, share and subscribe to my channel. Thank you.